Okay, I think that we're live, so we'll go ahead and get started. Uh, Greetings, everyone, and welcome in to my channel. I am Professor L, and this is a live stream for math tutoring. So if you want to post a math problem in the chat, I will definitely give it a try. In the meantime, I am going to be sketching a graph. And I'm just kind of picking up where I left off yesterday. Hopefully my technology is cooperative today. I had a lot of issues yesterday and I don't really know what happened, so I didn't do anything differently to resolve the issue. So if it persists, then I will do something about it. Or at least try to research what's going on with it. Anyway, what I decided to do was, because I watched the video that was posted yesterday, it was like a compilation of like 3 different attempts to have the stream. Was interesting. I think that was the smoothest so far. Whenever I have connection issues, that it seemed, but it was still choppy, and I think that I was able to demonstrate the how to calculate the inverse of this function, which is here. And so what I've decided to do is just use the stream tonight to go ahead and just sketch a really good graph of both of these functions. And I think I don't need that either. So I went ahead and started erasing some stuff because I went ahead and graphed this function yesterday, but I don't have it on video. So because my stream was losing connectivity, it didn't show the graph. And unfortunately, I did not catch it. I just simply, I don't get like a loud notification in here, and I do have a monitor that's right here next to my board, but I mean, unless I actually look at the screen, I'm not going to know that I'm having connectivity issues. So tragically, I taught or basically explained and worked on my board for 8 minutes, and it was just not even recording. So, and then there were like 2 episodes of that, so it was like double that. Anyway, it was fun, interesting. But I want to go ahead and sketch just a real quick graph. And basically, since I know I'm dealing with a log function and a exponential function, I have these 2 basic general graphs. This one is the a to the x, and this one would be log a of x. So those are both the general behaviors. I know that the exponential function, this one here, is most likely not going to have an x-intercept, but it will have a y-intercept. So when I go to first generally sketch the graph of the inverse, I know that I'm going to go ahead and let x be 0 and figure out what y is doing. So that's what I'm going to do. I'm going to say, use this function, and I'm just going to say f inverse of x. And instead of x, I'm just going to plug in 0. And it's going to be 2 to the 0 divided by 2 to the 0 plus 1. And all I'm doing is taking this function here and I'm saying, when is this function 0? Or what is the behavior of this function when x is 0? This line right here, the y-axis. So that's 2 to the 0, which is 1. Anything raised to the 0 power is the quantity 1. And then this is 2 to the 0, which is 1 plus 1, which is 2. So that's giving me 1/2. So I have, when x is 0, I have y is 1/2. So we'll say that's 1. Say that's 1/2. And so we'll go ahead and draw a point right there. And then get my table set up. And then maybe I would want to know what this function is doing on either side of this point right here. So most likely it's existing when x is -1 and when x is +1. So we have this point. So we'll go down, we'll say -1, +1. We already know when x is 0, y is 1/2. And so f inverse of 1 is going to give us 2 to the first power divided by 2 to the first power plus 1. 2 to the first power is 2. And that's 2 plus 1, which is 3. So that's giving me 2/3. So 2/3 is just a little bit further. We'll see, it's right in there. Rough sketch, just guess. So we have 1, 2/3. And then now I'm going to, which the negative value is probably going to be a little bit more difficult, but let's see if we can do it. F inverse of -1 is going to give me 2 to the -1 over 2 to the -1 plus 1. So I have to figure out how to evaluate this. So that, I believe this is going to be 1/2 or 1/2 to the first power, which is just 2 divided by 1/2 to the first power plus 1. So that's just, and I'm writing upside down now. I don't know why I picked this spot, but I did. So 1/2 divided by 1/2 plus 1. So that's 2/2. So anything divided by itself is equal to 1. So that's 3/2. And then when you divide fractions, what you're doing is you're inverting and multiplying that second term, the denominator. So that's going to give me 1/2 times 2/3. 2's will reduce down, and that's giving me 1/3. So it looks like -1 is giving me a value of 1/3. So we'll say 1/3 is, well, it's slightly less than 1/2. It's more than 1/4, and it's less than 1/2. So we'll say it's right in here somewhere. And so we'll have -1 1/3 here. And I don't know that we need any more points than that. This is the behavior of this graph. And this is the, this was the inverse. And this was negative infinity, positive infinity. All right, so we've got that math. So now let's go over here and think about this log function. And we're going to need a table. And I'll probably try to look at the same 3 points. However, if one of my values for x go to zeros, that's going to be an issue because look where the log function lives. It lives where x is positive, only when x is positive. So if we get into zero land, let's just see what happens. Let's see, -1, 0, and 1. I just want to try it. So we have y equal log 2 of -1 over 1 minus, will this be overall? I think it will overall be negative. So I erase the forms, but we have a to the y equal x and log a of x equal y. So y equal log. I don't know why I wrote it backwards. Let me erase that. I do get things flipped around a lot. So y equal log a of x. I really think that you can't. So what I'm going to do is, I'm pretty sure this is not going to be legal, but I'm going to change this to exponential form. So this is going to be 2 to the y equal x over 1 minus x. I think. And then I'm pretty sure what you have to do is we're going to have to plug in values, because what we're doing is we're switching the domain and range. So I'm going to put these values in for y. -1, 0, and 1. And then instead of evaluating the function at x, we'll evaluate the function at y, which is backwards. But it's going to be legal, really. It's fair. So what we'll do is, 2 when y is -1 equal x over 1 minus x. And let me see if I can somehow, let's see what happens with this first one. Let's just see. This is going to be 1 minus x times 1 minus x. And this is 1 minus x times 2 to the -1 is 1/2. And then these cancel and you're left with x. So this is going to give you 1/2 minus 1/2 x equal x. And then add 1/2 x to both sides. And that's 1/2 equal, let's see, if we, well, 1/2 plus 1 is 3/2. That's 2 over 2x. That's the way I think about it. 3/2 x. So then we'll divide off the 3/2 from both sides. And I feel like I've ended up having to divide fractions a whole lot today. But we've got 1/2 divided by 3/2. So that's going to be 1/2 times 2 over 3, which is 1/3. Interesting. So we've got 1/3. And we can verify that because we already have these points here. So when we plug in 0 here, we should get 1/2. So let's try it. It should check out. I need to, let's see, we can try to see if we can write smaller here. So 2 to 0 equals x over 1 minus x. One minus x times 1 minus x. I ran out of room, so that's going to give me 2 to the, 0 is 1, so that's 1 minus x equals x. Those cancel. 2 to 0 is the quantity 1, and then you just get what's in the parentheses, add x to both sides, and you're going to get 1 equal 2x divided by 2. And we get 1/2. I am really curious what happens. So let me see if I can plug in. Let me see what happens. Okay, 20 minutes, not too bad. So yeah, x is going to equal 1/2. And so similarly, adversely here, we have 2/3 for 1. When y is 1, we're going to get x is 2/3. What happens? I want to try to solve this one now real quick before we, we'll come back to it. We'll go ahead and calculate this last one. 2 to the first power. Just plugging in 1 for y here and solving this. X over 1 minus x, and we're going to multiply 1 minus x times both sides. And that's going to give me 2 minus 2x, because 2 to the first power is just 2. And those will cancel again, and you have x here. And then we're going to combine our variables. So we have to add 2x to both sides. And that's going to be 2 equal 3x. And now we will divide off the 3. And that is giving me, I need to learn how to not get in the way of my writing. 2/3, which we already predicted here. But I don't want to get off topic. I want to go ahead and complete the task that I planned on. So let's go ahead and sketch this graph real quick. And we'll start with 1/3, -1. So when x is 1/3, let's see, we'll say that's 1/2. And I think it's not very symmetrical here, so I think I can actually fix this a little bit. So we'll say that's 1. That looks better, I think. Okay. So we'll say that's 1/2, and so then maybe that's 1/3, because that would be 1/4. So yeah, so this would be 1/3. When x is 1/3, y is -1. So we have that point right there on the graph, just going off of this table here. And so then when x is 1/2, right here, 1/2, we're at 0. And then it says when x is 2/3, so we are talking, let's see, 3/4. 2/3 is bigger than 3/4, isn't it? No, it's not. I feel like I should have known that. Okay, so we've got 3/4, and just on the other side of 3/4, or the inside of 3/4, we have 2/3. So 2/3, comma 1 is on there. That's not 1/2 though. This one is 1, 2/3. So this one's going to be 2/3, 1. So it's just on the other side of the intersection. So this one, wait. I guess that's what that, this one. So 3/4, 2/3, 1. Right there. So that's real close to that one. That one's 1. Wait a second. 1, 2/3 is here. So this one's not sketched accurately. Hang on. Because I moved this point, I have to move this one as well. So this one, 1, 2/3 is here. So we have, there we go. It's like, what's going on? All right, and so now we have 2/3, 1, which is right here. Oh, no, that's more like 1/2. Get it together, Professor. Okay. And I can do a little bit better than that one. Let me just try one more time. And it's like asking people to have as much patience as I do. And it's just not fair. All right, get those points clean on there. And I did not anticipate having this much trouble, but all right, I think we got it. I need a smaller eraser because we like these little tiny Things on there, it's bothering me. Okay, so I think that is, it's a rough sketch, but I think we got it. And then also that identity function line, I feel like that we could possibly get some more points in here, like 1, 2, 3. Figure out what these points are doing, but like at least 2, right? So it would be 1, 2 here, and 2, -2 here. Tough call. So we have, it's such a small graph. I'm gonna go ahead and erase my work. And what I want to do, I think, is I'm going to try to make this one a little bit more user-friendly. And get it in terms of x. And c, because if I'm going to go ahead and do expand the table, I'll just go ahead and raise it. We'll say, let's see what's going on at -2 x comma y and +2. We could do that. It's a lot of work. Okay. Erase that one. And so what we have is, we have this right here. So f inverse of -2 is going to be 2 to the -2 divided by 2 to the -2 plus 1. So this is going to be 1 over 2 squared divided by 1 over 2 squared plus 1. And this would be 1/4 over 1/4 plus, and then right here, I'll just turn that to a equivalent fraction and say that's 4/4. So that would be 1/4 divided by 5/4. And then, so that's 1/4 times 4/5. 4's cancel, and you got 1/5. So at -2, we're at 1/5. And then +2, we're on f inverse of 2. See if I can fit it down here in this corner. Is going to be 2 to the squared over 2 squared plus 1. And then that's going to equal 4 over 4. The 2 squared is 4 plus 1. So that is going to be 4 over 5. So at 2, right here, we're at, it looks like 4/5. It is not growing that much. So see, 4/5 is real close to 1. Wait a second. I have to be wrong about this function. There's no way. Okay, so we have this one here. 2 is not quite to 1. Why did I erase this one? We'll check that one. It's this graph that I'm looking at. So 2, we're at 4/5, we'll say right there. And -2, it's 1/5. So 1/5 is like right in there. So most likely it's maintaining that x-axis intercept or asymptote. So when y equals 0, the function, there's an asymptote. And that's still this, I've got this thing all loosey goosey. I figure out what's going on with this log function here. So we'll see what's going on at 2, and this one was 2/3, 1. Okay. So I'm really curious to see what this log function is doing at 2 and negative. Well, it's obviously not out here at -2. So we'll have to say -2 and +2 on the y-axis here. So we'll come over, we did the easy part first. Now we're gonna do the hard part, and this shouldn't take too long, but we'll see what happens. So I'm just gonna try to see if I can solve this for x real quick. So that's gonna be 1 minus x, both sides. So I'm just going to subtract the quantity 2 to the y from both sides, and then also subtract the quantity x from both sides. That goes to 0, and I'm left with -x minus x 2y. That goes to 0, and then equals -2 to the y. And then we're going to divide off the negative. So if I just multiply everything by a -1, I'm going to get x plus x times 2y equal to 1. And then we will factor out the x. And that's going to give me 1 plus 2y equal to y. And then we will divide off the 1 plus 2y. And this is exactly how we calculated that inverse. So this is going to give me the inverse in, those are going to cancel. So I'm going to get x equal 2 to the y over 1 plus 2 to the y. Right, that'll make it a little bit easier. I should have known I could just swap out the x's and y's. So let's go ahead and plug in -2 here. So 2 to the negative 2 divided by 1 plus 2 to the negative 2. And that's x equals. So this is going to be x equals 1 over 2 squared divided by 1 plus 1 over 2 squared. And it's giving me the same process here because so it's just giving me the same number. So I know that it's going to be 1/5. And then I know that this one's going to be 4/5. So I can just hurry up and sketch this real quick. Leave the suspense. We have 1/5 is going to be real close to the 0 here. Because that was 1/4. So 1/5 is probably right here. And so we have 1/5 negative 2. So here we go. We're getting real close to that y-axis and we're not going to touch it. So that's probably still an asymptote. And then it was 1/2. And then at, see, 4/5, which is almost to 1, we're at 2. So we know that that's there. All right, so there's a little bit more of the graph. And we also have this f of x equal x, which is that y, it's that identity function line. So we have 1 and 2 negative 2, and we can get our ruler out. And look at that symmetry, because inverses should share that symmetry about the identity function line. So we'll just get a couple of points in here lined up. Maybe one's kind of off. Oops, I was off, no. And it should intersect it right there. That's pretty cool. All right, so we have perfect symmetry there about the identity function line. So that guarantees us that we have found our inverse graphically and verified it. And that was fun. 40 minutes, and looks like I still have my technologies working. But that's been long enough, I think, for the day. And yeah, if you have a math problem you want to see me work out, that would be fun. But if not, that's okay. I'll figure out something else productive to put on my board. Yeah, so if you're watching my videos, I really appreciate it. Thank you so much. And I look forward to working with them and working on my board every day. It has been challenging, but I think that I'm doing well so far, and the feedback that I'm getting has been pretty good. I haven't really got any negative feedback yet, so I guess that's encouraging. But yeah, so I'll quit rambling, and definitely want to remind everyone that if you do tune in and you happen to see my video, that I just started a couple months ago, and trying to use this platform to maybe engage with students in real time, and we'll just see how it goes. I know it's kind of like a new concept. I really am not aware of a lot of streamers doing this for math. And so, yeah, I'm just excited to see what happens with it. And yeah, so thank you so much for watching again. And I will see you again tomorrow, same time, same place, between 6 and 7 p.m. Central. All right, bye for now.